Rhenium diboride contains a hexagonal crystal system formerly referred to as P63/MMC. The crystal structure of rhenium diboride consists of alternating layers of metallically bonded rhenium atoms and corrugated layers of boron atoms bonded in a continuous sheet of chair conformations. In terms of material properties, the strong covalent boron-boron bonds result in the material's strong resistance to mechanical deformation. Meanwhile, metallic rhenium bonds give the material the interesting property of metallic conductivity.
The structure of rhenium diboride is hexagonal. The rhenium atoms are located at points 1/3, 2/3, 1/4, and 1/3, 2/3, 3/4. The boron atoms are located at 2/3, 1/3, 0.048, and 1/3, 2/3, 0.548, and 2/3, 1/3, 0.354, and 1/3, 2/3, 0.982. The coordination numbers are 11 for boron, where there are 3 boron atoms and 8 rhenium atoms near each boron. The coordination number is 14 for rhenium, where there are 8 boron atoms and 6 rhenium atoms near it. The hexagonal crystal has lattice parameters of 2.9 angstroms and 7.478 angstroms.
Boron-boron bonds with lengths of 1.820 and 3.025 angstroms and bond energies in the structure of 8.281 and 4.114 electron volts respectively. Note that this deep symmetric Lennard-Jones graph implies a low thermal expansion coefficient. Additionally, the boron-boron bonds are very strong, which is important to the defect properties discussed shortly.
In terms of material strength, the movement of a defect in any direction that crosses a corrugated boron layer will require a greater amount of energy and thus a greater applied stress because it must break the strong boron-boron covalent bonds in order for the displacement to move. Importantly, this will be true for any crystallographic direction with a non-zero z-term. Meanwhile, in the 1110 plane, only boron-rhenium bonds must be broken and less stress is required for defects to move. For diffusion to occur, boron atoms move through the interstitial sites within the rhenium diboride lattice. Occupation of tetrahedral positions causes compressive stress, creating unit cell expansion. Thus, tetrahedral positions require higher energy to occupy compared to the octahedral sites. Thus, boron atoms diffuse via octahedral positions to reach their final position. Finally, rhenium diboride is formed from a parent liquid phase and has a phase diagram as displayed. Thanks for watching.